Okay, we've seen that we can find C1, C2, and C3, so that C1 V1 plus C2 V2 plus C3 V3 equals ABC for the three vectors 1, 0, 0, 1, 0, 1, 1, 1, 1, the V1, V2, V3 vectors, which also appear in these columns. We find that we can do that if we simply multiply the vector ABC by the inverse matrix that's inverse to this matrix. And it's obvious that if we multiply both sides by the inverse of this matrix, we get a solution for C1, C2, and C3. Okay, well, I went ahead and inverted the matrix. And I believe, if I did this right, that the inverse matrix is 1, 0, columns 1, 0, 0, 0, negative 1, 0, negative 1, 1, 0. Multiply this vector by ABC, we get our values of C1, C2, C3 for any vector in R3. Whatever the vector is, call the first coordinate A, second coordinate B, third coordinate C, and multiply this matrix by the resulting column vector. Okay, well, now we have, let's say, three vectors, W1, W2, W3. And I'm looking for it. I thought we had worked out the inverse matrix, but okay, for the vectors W1, W2, and W3, which are also given, those vectors being 1, 0, 0, 1, 1, 0, 0, 0, 1, we can multiply by the inverse of this matrix to get another set of coordinates, D1, D2, D3, that have the same kind of properties. That is, D1 times W1 plus D2 times W2 plus D3 times W3 will add up to the vector ABC. So that the vector ABC is equal to C1 V1 plus C2 V2 plus C3 V3. It's also equal to D1 W1 plus B2 W2 plus D3 W3. Okay, well, then I'm going to say that C1, C2, C3 equals A inverse times the vector ABC, where A inverse is, well, A is the matrix that we have here. And again, as we've seen, we multiply the vector ABC by A inverse, okay, by the inverse of this matrix to get the C1, C2, C3. And the D1, D2, D3 will be B inverse times the vector ABC, where B is this matrix. So let's make that real explicit. A is the matrix 1, 0, 0 column, column 1, 0, 1, column 1, 1, 1. B is the matrix with the W vectors in the column 1, 0, 0, 1, 1, 0, 0, 0, 1. Okay, so if C1, C2, C3 is A inverse times ABC, and D1, D2, D3 is B inverse times ABC, then what would we multiply by the column vector C1, C2, C3 in order to get the column vector D1, D2, D3? Okay, well, you should think about that. But if the column vector C1, C2, C3 is A inverse times the ABC column, then A times C1, C2, C3 will equal the ABC column, so that we can replace the ABC column by A inverse times C1, C2, C3. Now, I said that by pointing out, and by pointing to it, let's write it out kind of carefully. Okay, ABC equals A times C1, C2, C3. Now if we take this form of ABC and plug it in here, what do we get? We get D1, D2, D3 equals B inverse times the ABC vector, but that's going to be B inverse times A times the C1, C2, C3 vector. And I should have that written out here someplace. I do. So I'm going to have to move the board over. And we have this. Okay, so that the D1, D2, D3 vector is the B inverse matrix times the A matrix times the C1, C2, C3 column vector. Okay, we have now three vectors, V1, V2, V3, that we've seen span R3. So this set of three vectors forms a basis of the space R3. We also can easily show that these three vectors span R3. So this is a basis that we'll call B2 of the space R3. C1, C2, C3 with a subscript, the column vector C1, C2, C3 with subscript B1 then expresses ABC in terms of the basis B1. So, and this C1, C2, C3 just means C1 times the first basis vector plus C2 times the second basis vector plus C3 times the third basis vector. That is, in this case, well, I'm not going to read them to you. They're all the way across the board. I was going to, but I'm not going to. Okay, so since then C1 C plus V1 plus C2 V2 plus C3 V3 equals the ABC vector. D1, D2, D3 with respect to the basis B2 expresses ABC in terms of the basis B2 in the sense that D1 times W1 plus D2 times W2 plus D3 times W3 added up will equal the vector ABC. The matrix B inverse A connects D1, D2, D3 and basis B2 with the C1, C2, C3 representation of the same vector in basis B1. So now if we don't know what the ABC is, we don't have to. If we know the C1, C2, C3, we can express this vector in terms of the basis B2 using the matrix B inverse A. Then you might think of, okay, well, what if we knew D1, D2, D3 with respect to B2? How would we find the C1, C2, C3 that express the same vector with respect to basis B1? So, very good question, worth thinking about.